Oh, what's the deal with meteorology? Why aren't they more accurate than? I mean, it's really broken, right? Like they don't know like what it's going to do tomorrow. Like, do we really want to know? Because I'm like planning my dad and I are going on a golf trip over spring break, so we're leaving this Friday, and we're driving because he doesn't like airports. So he doesn't mind flying. He doesn't like airports. He doesn't like the airport experience. So we're looking at all sorts of like drivable places, right? So we started off with Birmingham, Alabama, and we have reservations at all the hotels. But then the weather looked like it was going to be too rainy there, because I mean we started playing this a little bit ago, so you had to wait till about 2 weeks out before you get any sort of weather forecast. So then we changed it to Kansas City. In the last day, I guess you got fair truth in advertising. Last 2 days, Kansas City has gone for. This is on Sunday. It was originally supposed to be 65 and sunny. Now it's 40 with snow. How do you get that wrong? I mean, Mr. Gonzalez could roll like them, do the magic 8-ball thing, and do like as good of weather. I mean, how do you miss that? How do you go from like nice day and sunny to snow? So we literally have hotel reservations in like 5 different cities that aren't anywhere near each other. And the night before, I guess we're going to cancel all but one, and that's where we're driving, because you got to do the 24 hours or they charge a thing. It doesn't make any sense to me. Why aren't we better at weather?
Ask Mark Baden.
I mean, funny story about him. So he's on what channel? He's on CBS?
I'm not sure.
But he's one of the weather guys, yeah. I had seen him on TV a couple of times. This was maybe four years ago or something like that. I was down in Florida for one of my golf trips, and I was playing by myself at this kind of nice golf club down there called Jacaranda East. And they just pair you up with somebody. I get paired up with him. So 2 people from Mequon, 1,000 miles away, just randomly. It was pretty funny. So it was him, and I think it was his brother-in-law or something like that. In real life, he swears way more often than he does on TV. It's a lot of people do. It's kind of a thing.
You know that he teaches a class here, though, right?
Does he?
Yeah.
Oh, he swears way more often than he does on TV for a teacher at a Christian school. I mean, Christian professors shouldn't swear at all, right? Oh, you should see me when I'm out fishing. Lots of stuff happens there. Okay, so let's talk first about midterm. Well, actually, first, let's talk about CS Get Together. CS Get Together is this Thursday, right after you take your midterm. So it's gonna be, what is it, 11:30 down in that room down there. Make sure you show up early for the whole meet and greet dealy thing, so that you get what is that? Is that food? So make sure you show up early for the whole meet and greet thing, because that's the best prizes come from the winners of that. I don't know. Has there been a prize list released yet for this one? Dr. Locklear a lot of times releases a prize list, but usually there's an iPad or a Chromebook, or usually it's like an iPad and a Chromebook, or 2 or 3 prizes like at that level, like kind of good stuff. Then everything else is crap. So so you want to be one of those main winners, not one of the steerage as you go down that line. So show up to that. Free food. We usually have pizza and sandwiches and that kind of crap.
You cannot win when they have too many senior design people there. They're so fast.
Too many seniors?
Yes.
They're so fast?
Yeah.
What, they know too many answers? That has not been my experience with our seniors. Okay. My experience with our seniors has been just the sheer fear that we're about to give these people degrees.
True.
Terrible. All right, so before that, we have our midterm in here. So midterm will be 10 questions, all short answer essay programming, so no true false multiple choice, so the normal deal for my exams. Remember that I have the policy that if you do better on the final exam than you did in your midterm, I'll replace your midterm with whatever you get in your final exam. So you can't screw your whole semester's grade over from this one exam. You will always have a get out of jail free card. Well, not free, but if you perform on the final, you can get out of jail. Some of you will have some extra credit added to it if you've shown up to some of these recent extra credit opportunity things. So I'll when I hand back your test, it'll be the number you earned, and then I'll have the extra number on there so you can see that you got the credit for it. So you'll see how your grade was broken down. In the grade book, you'll just see your final, the total, so the actual grade plus any bonus you have. Otherwise, I'll lose track. Okay, so let's just flip through the slides real quick so I can point out any things that you should specifically prepare for the exam. Now, one thing as a general rule, as we become better and better programmers, you can expect more of the exam to be programming. All right, so like last semester, we would typically have like 3 programming questions or something like that on the exam out of the 10. We're probably talking more of half and half in here. So probably half the questions will be programming of some sort. The other half will be short answer-y type stuff. It might be I show you some code and ask you, what does this do? That kind of stuff. All right, so let me go through the slides quickly here and just point out things that you should certainly look at. This whole concept of speed is certainly going to be important. So somewhere on the exam, there's going to be a representation of arrays versus linked lists. One being, arrays being relatively fast, linked lists being memory efficient, and how do we care, or when do we care about that? So I don't know what form that question will come in, or maybe it's found in a couple of different questions, but that will be a topic that will show up on the exam. So that's these two things, speed and memory footprint. So when we first started talking about data structures, the idea of anything that holds data in some sort of specified format, and data structures perform at different speeds, similar to how we have cars. So we call anything we call a lot of different things cars, but cars have different performances associated with them and different ways of measuring what's good about a car. And we can't necessarily just blanketly say that a Corvette is better than a, pick your favorite SUV, an Escalade or something like that. They serve different purposes, right? You don't go with either of them if you want gas mileage. You go with like a Prius or one of the tiny cars. But the point is that different cars have different features, different things that are good about them. Same thing's true with data structures. So we want to use the right tool for the job. Okay, if you're pulling a boat, Corvette's probably not the choice, although it probably could pull a boat. It's got a lot of horsepower, I think, those things, but they don't have a lot of weight. So that's the problem with pulling a boat with those guys. I probably won't ask you questions specific about array lists. It's going to be more of just the concept of storing stuff, data structure-y type stuff. One of the programming questions very much might be me saying we need to store a certain data of a certain format and having you create a data structure or something like an object built for holding that kind of thing. We did talk about searching and sorting. We talked about binary search, right? In here. So binary and linear search, you should be able to write either of those. I probably wouldn't ask you to write a binary search code-wise on an exam, but I could give you a series of numbers and say, you know, how many comparisons, using a binary search, how many comparisons would it take to find the 8 or something like that. Okay, so you'd have to know how the binary search algorithm works, where you go to the middle, you know, divide it in half. Is this the guy? No. Should he come before or after this? Go to the middle of that guy. Is this the guy? Yes or no? So on and so forth. So you should know how the binary search algorithm works and be able to answer a question like that. Similarly, I guess you should be able to do the same thing with a linear search. I guess I would hope I don't ask that question, but I'm almost afraid to ask that question. Like if I gave you a list of 8 numbers, I say, how many comparisons would it take to find a certain number in here? I would give you one of the number, like how many comparisons would it take to find the number 4 using a linear search, which literally just starts at the beginning and checks, because I would be afraid how many would get that wrong. It just terrifies me. In fact, I might put that on there now. Yeah, expect that. Don't mess that up. That's like free points. Because like if it's the 4th thing, like I'm gonna. I have 4. There's 4 questions I have to ask to get to that guy. And I check the first one. Definitely. So I don't forget. Definitely at least one conversion question. So going from one base to another base. I just love those questions, and it also never ceases to amaze me the percent incorrect we get on those. Those should be automatic for us now. So bring a calculator if you want to use your phone, that's fine. If you need to borrow my phone to use the calculator, that's fine. I try to keep in mind that the numbers that you might be crunching, you know, that I don't give you crazy huge numbers since you're doing it, you know, sometimes off the top of your head or something, but you should know how to convert between bases. If I told you to convert the number, 13 in octal to hexadecimal, you should be able to do that. Okay? And there's lots of different ways you can pull that off. So, you know, the go-to method, if you don't know any of the tricks, might be to convert it to decimal and then decimal to your other base, right? But if I say octal to hex, that was actually a pretty easy move, right? What's the easiest way to do octal to hex? Somebody other than you. So for instance, if I said 13 octal to hex, how would you do that? Okay, so you go octal to binary, right?
And then group it by 4s for the.
Yep. So 0, 0, 1 for the 3, and then 1, 0, 1. No, actually, that's not right. 0, 1, 1 for the 3, 0, 0, 1 for the 1. So this is the binary version of this octal number, right? All right. Now I only have 6 elements here, so I need 2 extra padding here to give me my 4. So now this is the value. This is the 1s, 2s, 4s. This is the 8th place, right? The who? It's what, 11? 0, 0, 1 is the 1 in octal, correct? And then 0, 1, 1 is the 3 in octal. So there's the 2 groupings of 3 that make up that octal number. But now if I want to go to hex, I need groupings of 4. So I need to pad it out front with 2 extra zeros. All right, so the first hex number here is a 0, which we don't need to worry about. The second one, this is the 1's place, the 2's place, which is a 3. 8 plus 3 is 11, and what's an 11? A B? So 13 in octal is equal to B in hex. That make sense? So that's using our trick. Otherwise, you can take the 13 in octal if you want to convert it to decimal. You divide it by well, this is the ones place, this is the eights place, so you do the add up, so now you have the decimal, then you divide it by 16 over and over and over again to get you to the hex. So you can go either direction, whichever one makes the most sense to you, but be prepared for a conversion question of some sort. There might be a question dealing with recursion, so I could see a programming question dealing with recursion. We did a sorting algorithm. Did we do merge sort and quick sort or just quick sort? I know you read about both of them. We wrote quick sort, correct? So I probably wouldn't ask a question specifically about quick sort. It'd be more about maybe a programming question dealing with recursion, something like that. Yeah, that's where I would probably, I probably wouldn't ask you anything specific about quick sort or merge sort. So certainly linked lists, we spent quite a bit of time with them, as well as stacks. So those two guys will be represented on the exam. I might give you a stack of numbers, or I might give you some stuff and say, treat this as a stack, and then give you a series of pushes and pops and tell you to show me what the final version of the stack looks like, something like that, so you understand the nature of push, pop, and peek. So maybe the three different operations. So push adds something to the top, pop removes something from the top, peek just lets us look at the top without removing. Okay, so making you kind of read through a series of stack operations and showing me what the final version of the stack might look like after those operations. Make sense? So it also is just the idea of a linked list relative to arrays, where arrays are contiguous in memory very fast, but memory inefficient because they're contiguous, where linked lists are not contiguous, so they're relatively slow since we have to bounce around all throughout memory, but they are memory efficient since we can expand the size of a linked list trivially by just adding a new node and hooking it up. Okay? So at the performance side of things, understand the kind of the rationale behind when to use an array and when to use a linked list. Understanding that linked lists are not the upgrade to arrays. These two different animals have different purposes. Okay. I mean, I probably wouldn't ask you anything specifically about like doubling linked lists or tail and some of that, since we didn't actually implement that, but I don't think it's a huge stretch to understand what those guys are. But when I refer to a linked list, I'll probably think about it in terms of a singly linked list where you have to start at the beginning and traverse to the end. I might give you an implementation of a linked list and say, write the code necessary to add to the end or something like that, where you have to show me you can traverse the entire list and tack something onto the end, or maybe write a linear search on a linked list where you actually have to walk through it using the linked list operations to get a value and see if it matches what you're searching for, that kind of thing. So be able to use linked lists. Again, the concept of a stack, push, pop, peek, where push and pop are the primitive operations on a stack. Peek is kind of a convenience method, but still convenient, right? Just to be able to look at the top of it. Last in, first out queue for a stack, but I would certainly have you. I think a lot of the questions are going to be more programming style, whether it's you reading my code and telling me what the output is going to be, or you writing code of your own. It's going to be more along those lines than a whole lot of, discuss the pros and cons of two things or something like that. That doesn't mean a question like that won't exist, but I would think that a majority of the exam would be the other type. Okay. So, programming questions. So you do have an hour and 15 minutes to take the exam. Expect half of them probably to be questions where you're going to have to write some code. They won't all be monster questions. So that means, you might have to write a function that does something, or maybe even a for loop that does something. Just showing me that you understand the fundamentals, you understand object-oriented stuff. Maybe I might say, create a class that can represent this kind of data. If I say, we need an object called person that can hold a person's first name, last name, and age. Write the necessary constructor and getters and setters. You should be able to write that. Okay, that should be pretty easy. Where you create your 3 fields, you create your constructor that builds the 3 fields, and then you have your 3 getters and setters, or maybe I say just getters, whatever, so you don't have to write too much random stuff. But kind of common issues I see with that on exams, things that I'm looking for is when students write the constructor that takes no parameters and they hard code a couple of values in there, not really understanding that that object is the blueprint, and we use that blueprint someplace else to actually instantiate our objects. So I'll be looking for your understanding of how to make objects and that kind of stuff. That's going to show me your personal kind of programming, I guess, competency at the moment. I encourage you to work in groups on your homework assignments and stuff like that, but with an ultimate end game of that you're learning, that you're going to learn the stuff. So that means it's quite often that you're going to get together with somebody who you perceive as a pretty good programmer, and that person's getting out of it by teaching others. So looking at different ways to explain something to others makes the stronger programmer stronger. But at the same time, the weaker programmers need to also be getting stronger from that learning experience. If you're not getting out of that learning experience what you should be, well, I want to know about it now, but also it's most important that you know about it now, so that the second half of the semester you can adjust your homework habits or something like that, so you get a little bit more out of it, so you can come back and redeem yourself on the final. Make some sense? All right, so I won't be asking questions that are meant to trick you. The programming questions will be meant for you to show me your programming competence. You're probably not going to lose a lot of points on a question where you make a small little logic problem, but generally show me that you know what you're doing. But you'll lose all the points on a question where you just made stuff up and it doesn't look like syntax. Well, why don't I get a third of the credit because I wrote the word int? You want a cookie? The word int doesn't fly just randomly throwing out buzzwords. So I want you to show me some competence. All right, questions about the exam before we go on and do our Towers of Hanoi thing. Right, know what to expect? All right, so everybody should get an A. That would be awesome. That would be actually really awesome. Okay, so let's then go, and we're doing this in Android Studio now, right? So homework assignment was to, last time we had a kind of a functional game board, if you will, right? I wonder what's, Android Studio 2.3. All right, let's remind me later for that one. All right, so this is my version of it, right? Yeah, that's the one I checked out. This is my version. So last time we had like a functional prototype where we can move disks from, well, they're not disks at this point. They're we do them as text views. Our disks are currently represented as text views, and we can move from stack to stack to stack from our tower, but right now they're not towers. Right now they are, linear layouts, correct? So our homework assignment here was to actually implement the rules of Towers of Hanoi, which is going to mean that we're going to have to kind of take our implementation of Towers of Hanoi and wrap our representation objects with that. Okay, so when we did this in Eclipse using just traditional Java, what we did is we had each of our objects, the disk object knew how to display itself. The tower object knew how to display itself. Well, we don't have to have display methods right now because we actually have objects that show us the current display, which means that a tower probably needs to maintain a view, right? It needs to maintain, so tower 0, that object is going to maintain this linear layout, this vertical linear layout, this view, which is going to be its visual representation on the screen. Now, behind the scenes, we're probably going to maintain a stack so that we can apply the rules. Now, you could always apply the rules to the view as well, but that becomes a little bit maybe more cryptic. But nothing keeps us from having a stack representation of our Towers of Hanoi like we had before. And then also having the visual representation, just making sure we keep those two guys up to date. That makes sense? All right, so similarly with the disk, before we had some number of equal signs for our disk that represented the size of the disk, where now when we build a disk, we're going to pass it probably the text view that we want that disk to represent. All right, or we want to be the representation of that disk, the visual representation of that disk. All right, so let's kind of create those pieces first, because right now we have, this ability, which doesn't actually apply the rules, but allows us to move stuff around. So what we'll do is we'll go into disk here. And right now we have a string inside of disk, which attempts to teach us how to, let's do this. We have a string inside of disk that is the way a disk gets displayed. Well, we're going to go ahead and get rid of that. One of the reasons I want to do that is I want to, this will expose it'll create errors in our code, but it'll also expose for us the places that we need to change. All right, so it kind of makes it a little bit convenient. So we're going to go ahead, we're going to create a private text view. And this guy is going to be maybe called TV, something like that. I thought it was, isn't it an option enter? Does that do it? Yeah, there we go. All right, so that imported our text view. So we've replaced our string with that guy. When we build a disk, we're taking in a size, but instead of taking in a size, let's go ahead and take in that text view. So that's going to be our representation of that guy. Now, we're still probably need to know about the size of a disk. All right, so because all of our logic down here, when we try to push a disk onto a specific tower, we're asking about that disk's size. All right, so we're really maintaining two different pieces of information about a disk. What it looks like visually to everybody else, and then programmatically, what's its numeric size. All right, so we'll take in a size as well as a text view. All right, so for a disk, we're going to keep track of the numeric size of the disk that we can use for comparisons when we're manipulating our stacks. We'll have what it looks like, and then we'll keep track of the next disk, because that's how our stacks actually work, our stack data structures. We will not build a display string, so we can take all that code out, because our display string has been completely replaced by this text view. Make sense? All right. So we no longer have the ability for a disk to display itself. So we'll get rid of that. Now, a disk still knows how to get its next disk, because these are just stack abilities, right? We know how to set the next disk, and we know how to get the size of this guy that we're going to be using to numerically ask the question, can I move my object disk from this tower to this tower? If so, let's make the same thing happen visually on our screen. Right? So we have the game working just the way the game worked before, but then us having our screen update at the same time as the disks actually move. All right, so that's our new version of disk. So now we'll go in here to our tower. So our tower is going to keep track of the top disk in the tower. It's going to keep track of the number of elements that are currently in the tower. When we build a tower, we'll give it no disks. We also now have the ability to display a tower, which isn't something we need to do anymore, right? Because the tower is going to be visually displayed automatically for us on the screen. So we'll dump a tower's ability to display. We will, though, have the ability for a disk to pop off a tower. So when we do this, we're going to pop a disk. This is the disk we're going to return. This goes through and figures out if we're not equal to null, then we'll update our top of our tower, reduce the count for that tower, disconnect the disk to return completely, and then ultimately return that disk. Now, what we haven't done is we haven't physically removed that top of the tower from our view. So with our tower, we need to include, what do we call this guy? The view, something like that. Why is it having problems coming up with...
You gotta connect it to your package. Doesn't have like your app address or whatever.
Oh, because all the other one, I get it, because all these have the package that it belongs to at the top. This guy.
Okay.
All right. So back to tower here. So now when we build a tower, we want to pass in the view that represents that tower. So for our tower 0, that's going to be the far left vertical linear layout. So this guy's going to take in a view, the view, and we'll say this dot, the view is equal to the view. All right, so now we have a way of getting that guy. All right. Now, when we actually remove something from our tower, that is when we pop a disk off the top of the tower. So we're grabbing the thing that we want to return. If the top is not equal to null, we'll go ahead and do this stuff. This effectively says, if we're inside this if statement, this says we will be returning an actual disk, right? Because otherwise, this guy down here might be null. Okay? And actually, this is a potential bug in our code as it stands right now, where disk to return, we really probably want to have that code inside of this if statement because we might be trying to talk to a null value in an empty tower. So we'll move that here. So that's only a problem if we tried to make an illegal move, but we'll still move it anyways. So this if statement says, if this is an actual disk, if the top of this tower is something that exists, we're going to go ahead and update the new top to the guy that's after him, reduce the count that's in here, set the disk that we're disconnecting's next disk to null, so he's completely free. We're going to be putting him in our staging area, right? And then the last thing we want to do here is we want to update our view to have the visual disk removed from it. That makes sense? So what we're going to say is we're going to say this dot, the view dot, what's our thing for it? Is it remove child?
It has to be a view group.
Oh, view group, that's right. Now we should be able to do that. So we can say remove view at index. We can go ahead and we know the one we're removing is bucket 0. We can also tell it the actual view that we want to remove. It's up to us, but we'll go ahead and remove the view at position 0 in our view group. We don't need to preserve it or anything because we still have it preserved inside of the disk object that we're returning right here. So what does pop do? Pop returns an actual disk object, which comes with, because we wrote it this way, the text view associated with it. So when that disk object, when that text view gets added to our staging area, when we go to put it onto another tower, we'll just ask the disk, what is your text view? Give me your text view so I can go ahead and add it to the other tower. And we're going to see, we're going to have to give ourselves a getter for that here in a few minutes, but we'll let that organically happen. All right, so when we pop a disk off a tower, we'll grab the top of the tower programmatically. This has nothing to do with our views yet. As long as that guy is a real thing, then let's update to the new top of the tower. Effectively, this is what actually disconnects it. So those 3 lines completely disconnect the object disk from the top of our stack tower. And then we visually update our screen by removing from this tower's list of subviews the top disk. Okay? And our code is going to tell it to put that someplace else, but for right now, all we care about is making sure this tower maintains that its stack that its visual is a representation of the current state of its stack. Okay? Get count should work as is. Push, when we push a disk onto the stack, if the top is null, then we'll go ahead and set this guy to the top and we return true. Otherwise, we find out if this is legal. So it's always legal here. So after we increase the count of this guy, we want to go ahead and make sure we add the disk, add the view associated with the disk we're adding to this tower's view group. So we'll say this dot the view dot add view, and it probably doesn't matter how we do this, but we'll go ahead and force it at index 0. So we're going to add view. What view? D dot. Now we need to get the disk's text view. So we need to give ourselves a getter for that guy. So let's go into disk. Do generate a getter for our text view, and there's our text view. So we'll get the TV for that disk. So go back to our tower here. We're adding a view. What view? The text view associated with this disk. Where are we adding it? At position 0. You could have also just called add because we're inside of this if. That means we're dealing with the empty stack. Okay? Otherwise, and we have to do this in both places because this guy returns true up here to bail out of the function. So if we're allowed to make the move, that's what that if statement says, right? If the top of the tower is currently greater than the disk that we are trying to add, which means we're allowed to put it on there. Okay? If we're allowed to make the move, we'll go ahead and push it onto our stack. Then we'll update the top of our stack. We'll update the count, but then we also need to go ahead and make sure we keep our actual view group up to date with the stack data structure. Make sense? All right, so all we're really doing here is we're going through our original implementation of Towers of Hanoi and making sure we maintain these view groups to look the way they're supposed to look based on the current state of our stacks. Otherwise, we return false because we're not supposed to do anything. Okay? So that should be it for tower. Now, go back here. So that's disk and tower. Now in our main activity, this is where we have the things that deal with popping, right? When we take something off of one tower and we put it onto another tower, we need to have that work with our towers, which means now we need to create. Here we have our 3 towers, Tower 0, Tower 1, Tower 2. Those are our visuals. These are going to be part of what we're going to have for our Towers of Hanoi game, if you will. So what I'm going to do up here is we're going to go ahead and we're going to have a private tower called, we'll call that guy T0. Private tower T1. Private tower T2. All right, so these are our stack data structures that are going to be built in terms of those view groups. Okay, in fact, we can actually do this. I'm going to go ahead and name these guys Tower 0, Tower 1, Tower 2. And we're going to get rid of those guys. Because I don't need to have local variables here for my 3 view groups. I just need 3 tower data structures. We know that we've just augmented those tower data structures with the view groups, right? So we just need to build them with that in mind. So when we're building Tower 0 here, I'm going to go ahead and steal. We'll just steal this one here, and the rest of them will fall in line. So this guy is going to be a new tower. And when we build a tower, we saw that a tower takes in a view group. Okay, we need to hand that tower the view group that he is to maintain. So we're going to hand him that view group. Same thing here. Same thing here. So we will build our 3 tower data structures in terms of our 3 view groups. Because no longer is our main activity the guy who's directly manipulating what our view group looks like. Now it's the tower objects. It's just a level of abstraction, right? I mean, this isn't like new magical stuff. We've just said, towers, you're in charge of making sure your view group looks the same as your current data structure, your current stack that you're maintaining. Make sure those guys are in sync. Okay, if you pop something off your internal stack data structure, get it off of your view group as well. Okay, if something gets pushed back on, put it onto your view group as well. So each tower is now responsible for his own view group. Okay, make sense? All right, we have our staging area here. We probably want to keep our staging area separate because that's really all just the kind of a part of the board, right? We can almost think of our main activity here as our Towers of Hanoi board. Okay, so that our staging area is just a place for us to visually throw something. All right, now what we probably want to do though with our staging area is rather than that guy be a direct call him? I think rather than having our staging area be a... Well, rather than create a new animal, why don't we just do this? We'll do private disk. What do we call this guy? Like in limbo or something like that? The disk that's currently not a member of an individual tower. So the disk that currently is being represented in our staging area is kind of in limbo because he's not in one of the other towers. So, plus it's just a fun variable name, isn't it? So this is really a temp disk. So when we remove a disk from one of our towers and we actually get that disk object, we're going to put his view, his text view, inside of our staging area, so our staging area looks like a disk has moved there. Okay, but we probably need to keep track of the actual disk object that we removed from a tower so that there's still a pointer pointing to him so that we can eventually put him onto a new tower. That's kind of an important thing about what we're doing here, right? Okay, so we'll call him in limbo. So when we create our screen here, these top couple things are just the normal, build from your activity main stuff. We'll go ahead and build our staging area. Our staging area is just a view group that sits up there to hold that one disk. We'll build our 3 tower objects, and those objects are built in terms of the view groups that we have on our screen. Okay, so we've passed the buck. We've said, Tower 0, you're in charge of this linear layout. Tower 1, you're in charge of this linear layout. Tower 2, you're in charge of this linear layout. Okay, and we already wrote the code internally in these guys to manage that linear layout. When we pop, we remove something from the linear layout. When we push, we add something to that linear layout. Okay, so our towers now know how to maintain that stuff. Okay, this cur mode thing, that's the toggle back and forth. We're still good with that, right? That just keeps track of when you hit a button what it means. Okay, are we removing or are we putting something? Okay, so now when we say, if we press tower button 0, if we're in source mode, right now what we're doing is we are asking the question, are we allowed to remove something, right? Then we are actually doing the removal and stuff like that. We're toggling it to destination. All of this logic now happens inside of our tower object. Okay, notice we have an error here because tower 0 is no longer a view group. He's now a tower object that we built. Okay, so what we're going to do is, as long as the tower object has something in it. So if tower 0 dot get count is greater than 0. If there's something in there to pop, let's go ahead and do some stuff. All right, so what are we going to do? Well, we want to go ahead and get the disk that we're popping off of there. We happen to have a variable for that, so this is called in limbo, right? So we'll say this dot in limbo is equal to tower 0 dot pop. Okay, so now my in limbo variable, which is a disk object, which contains the text view for that disk, he is equal to the top of tower 0. We don't have to worry about removing a view here. That view was handled for us by tower 0. He kept himself up to date. Now, when we add something to our staging area, we're not adding temp. We're adding this dot in limbo dot get TV. We're adding the text view associated with the disk that's currently in limbo. That makes sense? Now, one thing I want us to really kind of emphasize here is this is kind of the first time, and kind of the reason I maybe chose this as the project. Towers of Hanoi is a simple enough game that we can visualize it without, it's not like memorizing the current state of a chessboard, right? Where you got all these moving parts and stuff. Towers of Hanoi is simple enough. Well, when we think about it, we're very much solving this like human beings would solve it. I'm taking a disk off the top of this tower. okay? And I want this staging area to represent this disk. In real life, we would just lay the disk there because this disk is a physical object. It looks like something, right? When you think about a Towers of Hanoi disk, a visual pops in mind, right? That visual is that disk's text view. That's what's in our mind, okay? So right here, we're saying, go ahead and throw into our staging area the visual version, what our in limbo disk looks like, okay? And then toggle our mode. Now we're only going to do this if there was something in that tower to pop. Otherwise, we're not going to toggle. If we're in source mode, that's what we're doing. If we're in destination mode, then what are we going to do? Well, this went ahead and gave us our disk. We already have our disk. It's called inlimbo.getTV, right? So we can get rid of that guy. We're going to remove that guy from our staging area. So our staging area clears himself out, okay? Now we're going to try to add to our tower. Now this is something that before we actually probably don't want to move it from the staging area yet. Before we didn't apply the Towers of Hanoi rules, right? So before what we said is, oh, we'll just let them move them all over the place just to make sure it works. Before we remove from our staging area, what we're going to try to do is we're going to try to add a disk to our, we're going to try to add a disk to our destination tower. All right. Now, one risk we might have, and this could actually be a crash risk with Android, is if we don't actually remove it with the possibility of maybe putting it back in a second, you might have a situation where you try to add the disk's text view into two different view groups, and then your app crashes. All right, so we will actually remove it for a moment. Then we'll try to add it to Tower 0 as the destination. If it worked, we'll flip-flop the cur mode. If it didn't work, we'll throw it back onto the staging area. All right, so it's off the staging area now. Now we'll try to add it. So we're going to try to push it onto our tower. Now if we go back here to our tower and we look at push, we know that push returns a Boolean. It tells us whether or not it worked. Okay? So inside here, we're going to say if this dot tower 0 dot push this dot in limbo, if that works, go ahead and flip the mode to source. Else, that must have been an illegal move. Therefore, we want to go ahead and put this guy back into the staging area. Okay? Now, when we flip it to source, we can also go ahead and say this dot in limbo is equal to null. We didn't have to do that, but let's go ahead and do that just to clean up after our own mess, right? Why have this guy pointing to a disk that has already found a new home? Right? At all points in time, we want in limbo to point to the disk that's currently in limbo. Well, if we just successfully pushed it onto a new tower, we currently do not have an in limbo disk. Now, in this else here, that means it did not work. We were not able to successfully get it onto that destination tower. Then in limbo does not clear out. Our cur mode does not toggle, but we do need to go ahead and throw our current disk's text view back into the staging area because nothing actually happened. So we'll say this dot staging area dot add view this dot in limbo dot get TV at bucket 0. So if it failed, go ahead and throw the current disk back onto the tower. That makes sense? Now what I'm going to do is I'm going to steal this code. And we'll update it for our other ones, just switching all tower zeros to tower ones and that stuff. So this is for tower 1. So we'll update tower 1 there. Update tower 1 there. Update tower 1 there. That should be it for that one, right? Does that look good? And same thing here for tower 2. Update tower 2. Tower 2. Tower 2. Did I get all of them? We're good? Okay. And then we'll go ahead and we'll stop this and we'll rerun it. And the working theory here, oh, I wonder why that popped up. Did I close my emulator before?
Where you stop it, it closes it.
Oh, does it? Years ago, that would have been really, really bad programming. In fact, for some of you, if you have AMD processors, it's still bad programming, right? Doesn't the emulator take roughly a week to launch? Do any of you have that issue where the emulator takes a really long time to launch, or is it pretty fast now?
Sometimes,
But what's really long?
like, when it says like Android, it's like starting to turn on, that could like say Android like that for like 5 minutes.
Oh, okay, yeah, that's almost as bad as. I mean, there used to be times where it would take a half hour for it to launch. Like legitimately, I'm not exaggerating. Where I would just tell students, you minimize it, it's open for the semester, right? It's the way it is. That's what the Intel Haxum thing is for. It's it uses your actual hardware to emulate Android. Actually, it's not emulating it; it's running it directly on Intel hardware. But it's fast then. Oh well, we do have one issue here. We're playing by the rules of Towers of Hanoi, but we're not starting off with Towers of Hanoi. Right? This guy looks a little sketch. So so let's go ahead and let's get our towers. Like, if this ever happens in one of my international competitions, you know, this is called a redo. Okay, it's a do-over. It's a technical term we use. It's a all right, so let's get these guys built correctly. So what did we do? Oh, because we have those disks currently exist in those. Okay, got it. So when we build this guy, so really we actually don't have any disk objects yet. We have all the logic around our disk objects, but we don't actually have disk objects. All right, so let's go out to our activity main here. Did we give these dudes name? That's disk 2. This must be disk 1. This disk 0. All right, so let's go ahead and give ourselves our 3 disks. All right, and we're going to go ahead and add those disks to our towers. Now, this is going to be a little bit weird. Probably the easiest way to do this is going to be. Is that going to work? Oh, wrong way.
So you just have to change it to wrap content.
Yeah. And then this guy goes here. And then it's wrap content for all 3 of these guys, right? Well, that's for the height. I do the same thing for the width. Oh, I made it upside down because I originally put it on there the correct way, but then it didn't look correct to me. Oh, it should be disk 0, disk 1, disk 2. All right, nailed it. Now we need to. Why is that one so tall? Why is that so tall? Oh, I grabbed the wrong. Okay, good enough. So that's how it's going to start looking, because you had us poorly design our widths. Yeah. Yep. I mean, I asked you for your professional input. I mean, this one's barely larger than the one above it.
I didn't plan the pro circuit.
I mean, there's big money at Towers of Hanoi International Federation professional stuff. I mean,
Wonder what the stats look like on that.
funny thing is, we're joking about it. There probably is some sort of like weird like underground like where people like have the because when we go online you can see that they have a different number of discs and a different number of towers where you have these dudes doing like speed runs of like 400 towers with 80 discs or something like that.
Errors recorded.
And the discs have like different weights to them, so it's almost like America or World Strongman. Like you may have like a 300 pound like the so it's yeah. I mean it's like man, I think we just had a great idea for like a reality show that only lasts a season, but so many shows only go one season, so it's like, is that really that big of a deal? I don't think.
The shame.
It's not like Survivor. Is it Survivor like season 48 or something like that now? It's ridiculous. Okay, so let's go ahead and give ourselves the disk text views, and we'll build disks in terms of those guys with their related sizes. It doesn't really matter what we put in for size as long as they're representative of they have to be relative to each other, right? So 0, 1, and 2 for the sizes is fine for this guy. So we'll go in here and we'll start off our game by adding 3 disks to tower 0. So we'll say this dot tower 0 dot push. This guy's going to take in a new disk, and the disk is built in terms of its size and its text view. Correct? All right. So this guy will have a size of 0, and then its text view. It's going to be the text view version of this dot find view by ID r.id.disk0. All right. Now disk 0 is the small one. Okay, so we actually need to add that one last. So this will be disk 1. This will be disk 2. All right, so we're pushing disk 2 on first, then we're pushing disk 1, then we're pushing disk 0. Okay, so this should catch our interface up, or catch our towers up to what our interface starts off looking like. Because our interface starts off looking like this, where our presumed tower 0 has 3 disks on it, but we didn't actually have disks representing those. Now we've thrown it in there for the beginning of the game. Okay. Bro. Oh, what we need to do is those guys where it's crashing because these guys was already on the tower, but now they're getting re-added to the tower. So I think what we need to do just to make this work is we'll come here. Yeah, we really need to give ourselves the disks. So we'll say disk D0 is equal to this guy. Actually, you know what? We don't need to do that. think we can just do a tower cannot give us the current tower, right? I'm going to give myself a little cheat function here. Public void clear this dot the view dot remove all subviews. So from a design perspective, we wanted to kind of be able to throw our 3 disks on this tower. But what we're going to do is right at the beginning, and I think this will be okay. I don't think we'll lose track of the views, but we'll see, is before I actually push the 3 actual disk objects on, I'm going to say this dot tower 0 dot clear. So I'll tell tower 0 to go ahead and remove all of its views. Disks don't exist yet anyways. Then we'll go ahead and we'll build the 3 disks and push them onto the tower. So the hope is when we clear this and actually get rid of those 3 text views, that we don't lose track and make this line illegal. If this breaks, then what we'll do is we'll create our 3 disks first, then we'll clear the tower, then we'll build our, we'll push the 3 onto the tower. So it won't be a big deal either way. Let's make sure this works. Yep, so crash. So we need to build our 3 disks first. Disk D0 is equal to this guy. Disk D1 is equal to this guy. Who would have thought the hardest part was going to be setting up the initial board? Disk D2 is equal to this guy. And then we'll push D2, D1, D0. So we'll go ahead and grab the 3 disks while those views still exist. Then we'll clear tower 0, which says get rid of all the stuff in that tower's view. Then we'll go ahead and naturally push them back on, which should put that tower back into the correct shape. You had a question?
I was just wondering why you put your clear function.
Oh, I literally told the view to remove all. It's like a cheat function. So I told this tower to tell his view to just get rid of all the subviews. Because initially these guys aren't actually disks, they're just text views. And we kind of don't want them there because we're going to actually push them on there. So after we maintain the disks, but this actually did teach us one thing, and that's if we remove, if we call clear first, which means that we got rid of the disk 0, disk 1, disk 2, the actual text views, from that point forward, those guys were then gone. Nobody else had pointers to them. So we couldn't actually create our variables with those in mind. Now we could because we maintained pointers to those 3 text views first. Then we cleared the tower. All right, so now we should be able to play Towers of Hanoi. So we'll go ahead and put that guy there. We'll try to put that guy there. We see it doesn't work. So we'll go ahead and put that guy there. Then we'll put this guy here. Then we'll put this guy here. This guy here. We'll try to cheat again here. Doesn't work. Put that guy there. And put that guy there. Technically, it's not detecting that we have a winner at this point, but we could have, a big flash winner, blah, blah, blah. Put in your PayPal address and send you big cash prizes. All right. Questions about our professional Towers of Hanoi app? All right, I think that pretty much fulfills it. All right, so no homework for next class except for study for the exam. Should I give you a really hard homework assignment over break? So you don't have anything better to do? I won't give you an assignment over break. So study hard, come in, do well on your exam. I will have the exams graded by end of day on, well, I say end of day, by end of morning Friday, because I leave for Illinois at like 4 p.m. on Friday, and I don't want to have any grading to do over my vacation. So you'll know how bad things were and be able to come to terms with it. I will, if I think any of you based on your performance should drop, I'll email you on Friday. But generally speaking, as long as you come in and do a good job, I like to encourage people to stick with it so you can replace your midterm with your final exam. All right. So, but if I really think you're beyond hope, I'll email you on Friday. So if you don't get an email from me on Friday saying that you should just drop immediately, change majors, then don't be too hard on yourself. All right. I will see everybody on Thursday. Don't forget about the student get together, Daily Flippy on Thursday. Also, today is student, faculty, staff Bible study. Starts at noon to 1. Get free lunch. Go to the cafeteria. Just sign in, get your tray, and take it down to the terrace room.
My
One second.
game is broken.
Your game is broken. Okay,
It
hold
only
on.
has